Hello everyone, welcome. Today we'll discuss the ISC chemistry paper in short, and we will see what should be the expected answers and the marking scheme. So let us start. In this part, as I said earlier during the discussion of the specimen copy, that for both the blanks you have to write the answer. Only then if one is correct you will get the half marks. So I am just showing you the answers. There is nothing much to discuss here. It will be dry cell, that is the primary cell, and nickel cadmium cell is the secondary cell. Nickel tetracarbonyl, this is a tetrahedral complex and the nickel is in zero state. Acetaldehyde is treated with hydrazine and KOH. This is your Wolff-Kishner reduction. So acetaldehyde will give ethane and the reaction is Wolff-Kishner reduction. And in this question, the transition metal ions having completely filled d orbitals are colorless. Since the word colorless is given here, so it has to be completely filled d orbital, and since it is completely filled, so no question of unpaired electrons, so it will be diamagnetic in nature. So here are the answers. Now come to the MCQs. For the first one, it is clearly mentioned that methyl isocyanide, actually both aniline and methylamine will respond to the carbolamine test, but since it is clearly mentioned methyl isocyanide, so the answer will be chloroform and methylamine, not aniline. In the next case, the answer will be P and R. P is correct because it is a colligative property, so it will depend on number of moles or number of solute particles. And statement R is also correct because pi equals to CRT. So with increase in temperature, the osmotic pressure will increase. Here phenol will be the strongest acid, aromatic. So it is resonance stabilized, the conjugate base phenoxide. So phenol is the most acidic here. Next, does not give silver mirror, so the non-reducing sugar you have to select here, and that is sucrose here. And in the complex, the en ethylene diamine, this is a bidentate ligand, so 4 2 ligand, 2 into 2 4 donor atoms and 2 water, another 2, so total 6, so coordination number will be 6. And the charge of 3 chlorine is -3, so the complex ion must be +3. All the ligands are neutral ligands, so the metal will be in +3 state, so answer will be option D. Now this one was a tricky question. Apparently it looks like A should be the correct or B should be the correct answer, but actually C will be the correct answer because it is written anhydrous FeCl3 prepared nucleophile. But when you use anhydrous FeCl3 and chlorine for the chlorination of benzene, that is an electrophilic substitution reaction. So FeCl3 actually prepare electrophile to attack the benzene ring. So here answer will be option C. Assertion is true, but reason is false. And number 7, option A is correct. That is the correct explanation. So here are the answers. Now for this question, I am showing you the calculation how to find the correct order from the unit system. This is the general formula: mole per liter whole to the power 1 minus n second inverse if n is the order. And from here, if you calculate, you find order equals to 3. And there are many differences between order and molecularity. You can write any one. The best difference is order can be positive, negative, fraction, 0, but molecularity is always a positive whole number. And in the third question, you can see it is 2a giving b, so the molecularity and order are not equal. Order is 3 by 2 because we are getting it from the red equation, and since the order and molecularity are not equal, that means it is not an elementary reaction. It is a complex or multi-step reaction, and you know, for complex reaction molecularity is not defined. For each and every elementary step in the mechanism, you can find individually the molecularity, but there is no overall molecularity. So molecularity cannot be determined in this case. Now here I have question 2, 3, 4, 5. So let us see the answers. In question 2, you can directly put this formula. Actually we write it EIT by F, I in ampere, T in second. IT is nothing but Coulomb charge. So here the only thing that you have to be careful is about the E, equivalent weight. So it is aluminium and 3 electron process, so the N factor will be 3. So atomic weight by 3, that will be the equivalent weight. and W is given 4.75 gram, F is 96500. So simply using the calculator you can get the answer. In the next part, this will be the answer. These four are the compounds that you have to identify. You can write either the structural formula or the name. Both will be correct. Then in question 4, it is given. So this will be the rate equation. And in the second case, NO is doubled and O2 concentration is half. So simply you take the ratio and you come to know that the rate will decrease by 2 times. Either you write it will decrease by 2 times, or you can write it will become half of the initial rate. And when the concentration of NO is taken very greater than O2, then it becomes a pseudo order reaction. So the one which is taken in excess with the rate of the reaction will not depend on the concentration of that component. So this K into NO itself becomes a constant which is written as K observed, and it will depend only on the concentration of O2 whose power is 2. So the reaction will now behaves like a second order reaction. So the order will become 2 here. In question number 5, compound A will be a tertiary butyl bromide. So this is a 3-degree bromide. So it will undergo SN1 mechanism, and in SN1 mechanism, in the rate determining step, the KOH is not involved. So the rate will not depend on the concentration of OH minus. It will depend only on concentration of A. But compound B is the isomer, which is a 1-degree bromide, that is the N-bromobutane. And here being 1 degree, it will undergo SN2 mechanism, which is an elementary reaction, and both this compound B and KOH are involved in the rate determining step. So here the rate will depend on both compound concentration of compound B as well as concentration of KOH. Now question number 6, ethyl cyanide reduced by lithium aluminum hydride aniline treated with bromine water. Then you have this question regarding coordination compound and then this order. So now come to the answers. Ethyl cyanide, this lithium aluminum hydride will provide the hydrogen for the reduction. Here the only point you have to be careful is the number of carbon, that is often seen as a mistake. Students forget to count this carbon of cyanide. So it will be propylamine, not ethylamine. And aniline, it will take 3 moles of bromine in presence of water. Here water is masked, so it will give you 2,4,6 tribromanoaniline, which is a white precipitate, pinkish white precipitate. And don't forget to write the byproduct 3HBr. Now the ionization isomer, so simply you will exchange the chlorine and sulfate. Now sulfate will become the counter ion and chlorine will become the ligand. So that will be your complex. Now if this is your complex, sulfate being the counter ion is ionizable now. So if you add barium chloride, then it will give you the heavy white precipitate of barium sulfate. In that way you can identify this ionization isomer. And this will be the name. Here in case of amine it will be double M, but ethane 1,2-diamine it will be only 1M. And order of acidic strength, it can be simply explained by the minus I effect of fluorine, chlorine, etc. Stronger the minus I effect, the electron withdrawing effect, more acidic is the alcohol. And order of boiling point, this is a dihydric alcohol, and you know glycerol, ethylene glycol, they are a little bit viscous. There is extensive hydrogen bonding. Molecular weight is also greater than the ethanol or ethyl chloride. So it will be less volatile. So the boiling point will be higher. And in case of ethyl chloride, there is no question of hydrogen bonding. So that will have low boiling point. Now question number 9, 10 and 11. Let us come to the answer. So in question number 9, again, either you write the structural formula or the name. Anyone you will get the full marks for the identification, either name or structural formula. And for the conversion here, benzaldehyde, first you oxidize it to benzoic acid, then convert it into sodium benzoate, simple acid base neutralization reaction, and then heat it with soda lime. Then CO2 will be eliminated, that will react with NaOH and become Na2CO3. Calcium oxide is the catalyst here, and you get benzene via decarboxylation. And for benzoic acid to benzaldehyde, you can use either PCl5 or SOCl2 to get the benzyl chloride, and then perform this Rosenman reduction to get the benzaldehyde. Now this is a simple Nernst equation question. If you write the balanced cell reaction, you will see nickel 2 plus is in the right side and copper 2 plus in the left side. So this will be the expression of Q, the reaction quotient. And then it is a simple calculation to get E naught cell 0.6196 volt. Now for the next question, It was given ethanol versus propan 1L. I have used tolerance test here. You can use iodoform test also. Propan 1L will give negative test for iodoform. It will not give the precipitate of iodoform, but ethanol will give positive. Otherwise, you can use Fellings test also. In that case, propan 1L will respond brick red PPT of cuprous oxide. Ethanol will not. So either tolerance or Fellings or iodoform. But remember, you have to write the observation for both the compounds, only then you will get half plus half 1, that is the full marks. Similarly, for phenol versus benzoic acid, you can use bromine water test, or you can use azodite test also, or you can use sodium bicarbonate, where benzoic acid solution will give effervescence of carbon dioxide, but your phenol will not. However, neutral FeCl3 test will be a little bit controversial, because in case of neutral FeCl3, phenol will give the characteristic purple or violet color, but benzoic acid will also give a buff precipitate that you perform in practical exam. But most of you may write that there will be no characteristic observation. So to be on the safe side for this question, bromine water test or azodite test will be the best one. Now question number 12, identification again, and question number 13 related to the chapter solution. So for the identification, here again the same reduction, ethyl cyanide, it will be propylamine and then propanol. See here they have played a trick. This amine treated with HNO2, and the temperature purposefully they have given 0 to 5 degrees centigrade, so that you write CH3 CH2 CH2 N2Cl. You think that it is diazonium chloride, but remember, when it is aliphatic amine, you cannot stop at the diazonium chloride stage. Doesn't matter how much lower the temperature is. For aliphatic case, it will always go to alcohol. Only in case of aromatic, you can stop at the diazonium stage if the temperature is below 5 degrees centigrade. So here it will be propanol, propan 1 all, not the diazonium salt. And in the next case, it will be again ethylamine, ethylamine, uh, carbylamine reaction giving you ethyl isocyanide, and ethyl isocyanide when reduced, you get the 2 degree amine, CH3CH2 NHCH3. Now in the next question, K4 FeCN6 will dissociate in this way. So 4 positive ion and 1 negative ion, so total 5 ions, so N will be 5, and then simply put the formula alpha equals to I minus 1 by N minus 1. Given alpha is 25%, that means 25 by 100 0.25, so you get I equals to 2. And in case of association, this is the formula, and for dimerization N equals to 2, and it is given complete association, so alpha equals to 1, so you get I equals to half. Now question number 14, simply you have to give the balanced equation, and then this question related to CFT of octahedral complex. So these are the balanced equation. You can take any alkyl bromide, or even if you wish you can take alkyl chloride also, then also Finkelstein reaction will take place. And here acetone, the solvent, is must. For Williamson synthesis, similarly you can take any suitable alkyl chloride or alkyl bromide with sodium alkoxide. And this is the Reimer-Tiemann reaction, the balanced reaction for Reimer-Tiemann reaction. There is another variety, CCl4. In that case, you will get COOH, that is the salicylic acid. Now, in the question of coordination compound, T2G4 Eg2, that means the electron is not coming from the Eg level to the T2G level. That means that is the high spin complex. So the one having T2G6 Eg0, where pairing is occurring, so you are getting less number of unpaired electron, so that will be the low spin complex. So complex B is the low spin complex here. And T2G4 Eg2, that means Eg2 the 2 electrons will be unpaired, and T2G4, that means one is paired, the other 2 are unpaired, so total 4 unpaired electrons. And T2G6 Eg0, so 3 orbital 6 electrons, that means there is no unpaired electron. And in complex A, since pairing is not occurring, that means the crystal field splitting energy CFSE delta O, that is less than the pairing energy. That is why it is not possible for the electron to come from the Eg level to the T2G level. So the type of the ligand is weak field ligand in case of complex A. Now question number 16 related to electrochemistry. Here we have two questions, and this is a little bit descriptive question. So between the two half cells, the one which is placed above in the electrochemical series, because in the electrochemical series they are placed according to their reduction potential. Higher reduction potential, they are at the top, lower reduction potential, they are below. And we know greater the reduction potential, the more easily they will be reduced, so they can become the cathode. That means in the electrochemical series, the system which is above, that will become the cathode reduction, and the one which is below, that will be the anode, that is the oxidation. Salt bridge, there are many functions of salt bridge. It completes the electrical circuit. It maintains the electrical neutrality of the electrolytic solution. It prevents the electrolytic solution from mixing. But the most important function is it efficiently eliminates the liquid junction potential, which is responsible for the potential drop. So that is the main function of a salt bridge. And this is again a theoretical question. Advantage of fuel cell, you can write any advantage. Here I have written provides continuous source of energy. You can write it is eco-friendly, less hazardous for the environment. Similarly, there are many disadvantages. I have written the expensive, the cost. You can write other factors also, any correct point. And the alternate question that was given, why specific conductance decreases with dilution. Specific conductance is the conductance of unit volume of solution, so it is related to the number of ions per unit volume. So when you are adding water, since the total volume is increasing, so the number of ions per unit volume will decrease, so obviously the specific conductance will decrease. Then E cell has to be positive for spontaneous cell reaction, because del G is minus in F E cell. N is number of moles of electron, always positive. F is 96500, that is also positive. So del G can be negative if and only if E cell is positive. So for spontaneous cell reaction, you need E cell positive. And this is the primary cell where the reaction is unidirectional, it cannot be reversed. And the disadvantage is itself the direction of the reaction, because you cannot recharge it. So after some time, after certain period, the cell will be dead, it cannot be reused. Now question number 17, this is nothing but the Zwitter ionic form, the bipolar ionic form. So this will be Zwitter ion or Zwitter ionic form of amino acid, and if R is hydrogen, it becomes the optically inactive amino acid, the only one, that is the glycine. So you can write it glycine. Next one is vitamin C, that is the its deficiency causes the scurvy, uh, related to your gums, teeth, etc. So it will be vitamin C or ascorbic acid. And the linkage that holds the monosaccharide units in disaccharide or any polysaccharide, that is known as glycosidic linkage, and the chemical nature is ether. So here are the answers: Zwitter ionic form, glycine, vitamin C, ascorbic acid, and glycosidic linkage. Now question number 18, this type of question one I have discussed in details in the specimen paper discussion in the previous video. So the same method we will follow and we can get the answer easily. First take the alpha and beta, the order with respect to NO and Cl2, and this becomes the rate equation. Now put the values from the number of experiments, then 2 divided 1 and 3 divided 1, you get the value of alpha and beta. So alpha plus beta will be the overall order, individual order alpha and beta, and when you put the value of alpha and beta in any of these three equation, you get the value of K. Here the important point is the unit of K, because the overall order is 3, so the unit of K will be mole to the power minus 2 liter square second inverse. Now question number 19, this is related to phenol. So phenol gives you picric acid. Either you can use this method or you can use the indirect method also, where the yield of picric acid increases, that is first sulfonation followed by nitration, or you can do direct nitration with mixed acid, strong oxidizing agent. So in this case, strong nitrating agent, sorry. So you can directly get picric acid, but again, yes, here the yield will not be very good, but this equation will work for to get full marks in ISC exam. Now why phenol is less soluble? Because it has a big C6H5 ring, phenyl ring, and that is rich in carbon. That means it becomes hydrophobic, so it does not want to go inside water, so it is less soluble. And then chlorobenzene to phenol, this is the Dawes process, 6 to 8% NaOH, high temperature, high pressure. First you get the sodium phenoxide, and then you perform the acidification to get the phenol. And in question number 4, it is clearly written that Lucas test positive after 5 minutes. That means the secondary alcohol. So with the given formula, the only secondary alcohol possible is butan 2-ol. And butan 2-ol, when oxidized, it gives you butan 2-one. Butan 2-one in presence of zinc amalgam concentrated HCl will undergo Clemmensen reduction to give you the corresponding alkane, that is N-butane. and this will be the balanced equation. Next, question number 20, titanium 3 plus titanium 4 plus. You just write the electronic configuration. You will see titanium 3 plus has one unpaired electron, so in the 3d orbital, so that can undergo dd transition showing color, and titanium 4 plus no unpaired electron, no question of dd transition, so it is colorless. Transition elements forms alloy. The key point here is the transition element atoms are of similar size because of the pore shielding effect of the d orbitals. Their sizes are similar, so one element can easily replace the atom of other element in the crystal lattice in the solid, so easily you can get the solid solution, which is known as alloy. And this number C, this is a very famous question that you perform in your titration. The KMnO4 colored, purple colored KMnO4, it is reduced to Mn2 plus, which is colorless. So the color fades or the color disappear. And balanced chemical equation, there is nothing to discuss. Just see the answer and you can check. And now we are coming to the last question related to osmotic pressure. So let us see the answer. The red blood corpuscle, it is put in a hypertonic solution, so obviously the intracellular liquid solvent that will come out of the cell, it will shrink, and in biological term this is known as plasmolysis. You can instead of writing due to osmosis, you can write it due to exoosmosis, a more biological term that is. And in the next question they are asking to prove that osmotic pressure is a colligative property, so you know pi equals to CRT. So temperature is not depending on the nature of solute, so only the term here you have to explain is the C. Now concentration, that depends on the amount of solute, not on the nature of solute. So this osmotic pressure will depend on the relative amount of solute with respect to the amount of solvent, but not on the chemical or physical nature of the solute. And in this question Na2SO4 were given, here you have to assume that it is undergoing complete dissociation, so it will give 2 Na plus 1 sulfate, so total 3 ions, so I will be 3, provided we assume complete dissociation, since percentage dissociation is not given or degree of dissociation is not given. So pi equals to I into CRT, and concentration C, molarity, that is 1000 W2 by M2V, and just put all these values. Even the value of R is already given, and this 0.0821, the unit is liter atmosphere per mole per Kelvin. So the final answer obtained will be in atmospheric unit. And this is again a theoretical question. You can consult any of your textbook. We take a reverse osmosis cell, and then we take the seawater and fresh water, keep them separated by a semi-permeable membrane. Nowadays very advanced level semi-permeable membrane has been invented. Okay, and then we put very high pressure on the seawater side so that reverse osmosis can take place, and as a result what happens, the fresh water, the solvent part that comes out from the seawater, that is collected and taken out through an outlet. So in this way the desalination of water is performed. For the alternate question there are numericals, so you can use relative lowering of vapor pressure also, but I have used directly the formula that the vapor pressure of a solution containing non-volatile solute is mole fraction of solvent into vapor pressure of pure solvent at the same temperature. So first I have found the mole fraction of water, that is the solvent, putting all these values, these are given, and then simply put P equals to x1 P naught, you get the answer 32.439 mm of Hg. In this question, the elevation in boiling point is 0.70 degrees centigrade. Now here a very important point, since it is a difference of temperature. So in this case, degree centigrade and Kelvin will give you same value. You don't need to add 273 since it is a difference of two temperature. So the delta TB is 0.70 Kelvin, and then put the formula delta TB equals to Kb into 1000 W2 by M2 W1. This is nothing but the molality. It is clearly written in the question that it is a non-electrolyte, so I equals to 1. So you don't need to write I, and the final answer coming 53.061, the molecular weight. And for the soda water case, according to Henry's law, we know that at a fixed temperature, if you increase the pressure, the solubility will increase. So in order to dissolve more amount of carbon dioxide in the water, the bottle is sealed under high pressure. So this are the expected answer and according to that the marking scheme will be set. In my previous video for the specimen paper, I have discussed in very detailed about the marking scheme, where half marks is given, where 1 marks is given. Here I just have discussed the answer so that you can predict your score. I hope you have done well, and I wish you all the best to get a good marks in your ISC exam. Thank you.